Okay, when we are talking about, first of all, this lesson is on arithmetic sequences, but not all sequences are arithmetic. So a sequence is just any list of numbers. So if you have a list of numbers given, we call it a sequence. But when is a sequence that is given arithmetic? What did you learn in your SQ3R? Katie?
It's when like the difference is like the same like changing.
Could you read what you're doing here? Thank you. Okay, so it's when the distance, did you say?
Common difference.
Common difference is the same. In other words, when you move from one term to the next term, what happens when you talk about a common difference? What's happening? Austin?
Like you add or subtract by the same.
Okay, you add or subtract by the same constant. In other words, it's going up by the same amount or it's going down by the same amount. So let's check to see if this sequence given here in number 1 is an arithmetic sequence or not. So to get from -3/4 to -1/4, this would be called showing work. This would be called showing support. What do you have to do?
Subtract.
Add 1/2. Or also add 2/4, right? Which is 1/2. You can write it either way. But maybe it's easier to see if we write it as fourths because these are all fourths. So -3 plus 2 is -1. So from -1/4 to +1/4. Okay, AJ?
Plus 1/2.
Plus 1/2, also known as 2/4. So -1 plus 2 is +1. So it gets us to 1/4. Well, if it lasts between the next two terms, we can say this is arithmetic, can't we? What is the difference between 1/4 and 3/4? What happens? How many fourths is it going?
2.
2/4 again. So we would say this is, so is an arithmetic sequence. And when we can claim that it is an arithmetic sequence, we should be able to identify a D value with D equal to what? 2/4, which that's probably not how the answer, if they asked you for the common difference, would be given in an answer bank. It would be given as 1/2. Okay, so. Okay, so we can show work that way. We're going to talk about another way that you can keep finding more terms, but I'm going to let you keep it this basic, okay? Anybody have any questions? How about the next one then? To get from -4 to -2, what do? Add 2. To get from -2 to 1?
Plus 3.
Add 3. To get from 1 to 5? Add 4. Is this an arithmetic sequence?
No.
No, not an arithmetic sequence. Because, why?
It's not going up by the same amount.
Okay, there's not a common difference. Not a common difference. Okay. Not an arithmetic sequence. No D. That's all we can say, common difference. No D. Now, this happens to be a special type of sequence because what pattern do you notice is going on though, AJ?
Every time you add, you go up by 1.
Yeah, it's increasing by 1. Every difference is increasing by 1. So that's going to make it a special type of sequence, but it doesn't happen to be an arithmetic sequence. It'll be a type that we will study later. Okay? So to find more terms for an arithmetic sequence, and this should be in your SQ3R somewhere, we are going to add, like, even if it's going down in value, we can still add. What do? We add what? A negative number. So we're going to add the common difference to, if we were going to keep finding more terms, what would we add that common difference to? The previous term. So if we were going to carry on that arithmetic sequence that we found in the beginning in number 1, the next term, we would add the 2/4, the 1/2, and we would have our next term. So we always just keep adding to the previous term, and that should get us the next term. Now, here's the thing, that we have to make sure that we can start understanding algebraic language. Can anybody tell me what the a sub n in that one is giving us? What is it representing in that formula, in that equation? Caden?
Alternatives.
Okay, it's the term you're looking for. Okay, the term you're looking for. So if they say to you, find such and such term, they want to know if we kept this sequence going, what would that term's value be? Well then, what is a sub n minus 1? What's that, Devin?
Well, it's the term you're looking for minus 1.
Okay, it's the term you're looking for minus 1, which would make it what?
Previous term.
The previous term. That would make it the previous term. And D is the common difference. So this is a way of saying what we just set up there where we filled in the blanks. To find more terms for an arithmetic sequence, add the common difference to the previous term. This is stating it algebraically. A sub n. So if you know 5 terms of the algebraic or the arithmetic sequence, and you're supposed to find the next term, the 6th term, 6 would be your n value. So a sub 6, the 6th term, you would arrive at it by taking a sub n minus 1. So 6 minus 1 is 5. So the 5th term would be the previous term, right? And then add the common difference to it. Devin?
How come our book shows us the equation differently?
There's a different equation that we're thinking about that we're coming to. This is just for finding the next one. Just always finding the next term. So if you just want to keep finding the next term, and then the next term, you can just keep using this. Just keep adding to the previous term the common difference, and you will get the next term. Now, there is another formula for what if they give us 5 terms of an arithmetic sequence, and they say, hey, you, find the 50th term. Would you want to have to do this 45 times? No. So there's going to be another formula that we can use in that case. So find the next 4 terms. Okay, now I'm not going to make you use that fancy, algebraic formula that makes it look so complicated. What we're going to do is, first of all, when we find the next terms of this one, we are going to, not because fractions are not always nice decimals, we're just going to get in the habit of keeping them as fractions and renaming them so that they have a common denominator, since we're going to be adding or subtracting, right? If we have a common difference, there's addition or subtraction going on, and we need common denominators for fractions when we want to add or subtract. So we're going to rename our sequence first of all. Rename. So what would be a common denominator? 8. Okay, well then does the first term need to be renamed? No, we'll leave it 3/8. How about the next term?
Yeah.
Yeah, what would it be?
6/8.
6/8, so we'll rename that one as 6/8. The next one? Don't need to rename it, so we'll leave it 9/8. And the last one? 12/8. Now, the reason we're renaming it is so that we can find the next 4 terms, but in reality, notice they simplified the terms, so we're not going to leave them all as 8s in the end. We still have to now go back and say, okay, simplified, this would be the next term, okay? So when we are finding what's our common difference in this one?
Going all the way to 3/8.
It's going up by 3/8, plus 3/8, plus 3/8, plus 3/8 every time. So our D is equal to 3/8. We don't have to put the plus. We always add our common difference, so sometimes it's positive, sometimes it's negative. Okay, so if we're going to add 3/8 every time, here's what I'm not gonna make you do. I am not gonna make you show me that 12/8 plus 3/8 is 15/8. I won't make you show me that, because you can do that in your head, right? So, we're gonna say the next 4 terms. And we're just gonna list them. What are they? Well, we just found that one, 15/8. What would the next one be? 18/8. The next one, 21/8. And 24/8, because they wanted us to find the next 4. Now, do you think we're gonna get to leave our answers like that though?
No.
No. Now, notice, were there any mixed numbers in the original sequence? Did they write any of them as mixed numbers? Could they have?
Yes.
Did they?
No.
Okay, so we're not going to either. We're not going to change the pattern of what's going on, but what we're going to change is they also weren't writing them all as eighths. They were giving the simplified ones their simplified, the ones that could be simplified, they were giving them their simplified name. So can 15/8 be simplified? No, so we'll just leave it as 15/8. How about 18/8?
Yes.
So what?
9/4.
9/4. 8, they're both divisible by 2. How about 21/8? No, there's nothing that goes into 21 that also goes into 8. How about 24/8?
Yes.
What is it?
3/4.
3/1, but you know what? That they will do that. That they will do that, okay? They just are not gonna put mixed numbers. Typically, you won't see mixed numbers in sequences because sometimes you might think that the whole number is a term and the fraction part is a term, and it gets too confusing. Okay, so this would be our final answer for this one. This is how we would find them in an answer bank in the back of the book or on a test or whatever. So questions about what you need to show or do to determine a arithmetic sequence, find the next few terms. Okay, then let's go to the back side. And now this is where we're going to do what Deb was talking about. This isn't how the book gave it. Well, no, this is the second one they gave you in your book. To find a later term of an arithmetic sequence, use this model. So it looks a little bit different, because now this should help us skip over all the terms we don't need and find the one they're asking us to find, so that we don't have to keep adding to the previous term until we finally get there. Okay? So what's our A sub n? Term you're looking for. Its value. Well, what's the A sub 1?
It's the first term.
It's the first term. So the sequence has to start somewhere. Well, what's the n? The term
Your multiple.
number you're looking for. So if they're asking you to find the 40th, n would be 40. So n is the term number. The difference. In the first one, we're looking for a term, its value. This one, we're trying to find the term number you're looking for. Being asked to find, whatever way you want to put that. So, A sub n is saying, okay, if you find the 40th term to be 2,000, that's 2,000 is the term that you were looking for. They wanted that term. If it's if we're just talking about n, now we're saying that is the 40th term. It's the number of the term they want you to find. It is the 40th one, or whichever one they're asking you for. And what's D again? The common difference. And don't forget, you always give a common difference if it is an arithmetic sequence. You identify. When should the common difference be positive? Well, so just glancing at a sequence, how would you say, I know the D has to be positive? It's going up, it's increasing in value, right? The numbers are increasing in value. When would it be negative then? If they're decreasing, if they're going down. Now, here's the crazy thing that happens with students when they're doing these arithmetic sequence problems. They get an answer and they're just happy they have an answer, but didn't go back and see if it made sense. The sequence was decreasing in value, but yet their answer ended up to be larger than the first term ever even was. Does that make sense? No. So you have to make sure, this is where you typically will get caught in the common difference. You did not make it negative when it should have been negative, or have it positive when it should have been positive. Okay, find the 60th term of the following sequence. So they're telling us this sequence, we don't even have to check it out. We can just go to work. Well, we need an a sub 1 value. What is it? 11. It's the first term. We need an n value. What is it? 60, because they want us to find the 60th term. And then now we do have to find the common difference. What is the common difference in this one, Devin?
-6.
-6. It is decreasing in value, therefore our common difference has to be negative. So it's going down 6 between terms. Okay, well now we're ready to fill into our formula. So a sub what? 60 equals 11 plus
60 minus 1
60 minus 1, and that's going to be multiplied times -6. Don't just write -6 behind there without parentheses or a multiplication dot, or you'll think it's subtraction. And then you'll do the problem wrong. Was this one of them in your SQ3Rs?
Yes.
Okay, well let's see if you got it right then. Okay, a sub 60. Are we going to add 11 to that 60 minus 1, or what are we going to do here? No. 11 plus 59 times -6. Don't try to do too much at once. So notice, we want the 60th term. This is saying 59 times you would have to subtract 6. Well, we're just taking the shortcut. 59 times you would have to subtract 6, and you would start at the beginning terms, and you would end up at the 60th. Okay, so what is our 59 times -6? -354, everybody agree? Okay, so we're getting closer. Our 60th term is?
-343.
Okay, -343. Is that what you got in your SQ3R?
Yeah.
Is that what the back of the book said?
Yeah.
Okay, then we're good. Does it make sense?
Yeah.
The sequence was decreasing and we're in a way in negative territory and we had to go 60 terms out, so it seems pretty reasonable, doesn't it? Okay, find the 15th term of this arithmetic sequence. Well, they gave it to us a little bit differently this time. They did not tell us they did not show us the beginning of the sequence. Could we start this sequence? What would it start at?
4.2.
4.2. What would its next term be?
5.6.
5.6. What would its next term be? 7. Well, it's definitely growing, right? Okay. So we are supposed to find the 15th term. So what is that 15 representing? What is that? What is, no, that's not our first
Term
term.
we're looking for.
It's the term number we're looking for. So in reality, we know that n is 15. So here's all of our given information right here. We know the n value, we know the first term, we know the common difference. That's all we need. A sub 15 should be equal to 4 and 2/10 plus 15 take away 1 times our common difference of 1.4. So in other words, instead of adding 1.4 14 times to the first term, we can take a shortcut to get there. What is 14 times 1 and 4/10?
15.4.
Everybody agree? I don't know that I do.
No,
Devin, what do you have?
19.6.
Yeah, 14 times 14 is 196, but then we have to move back a decimal point. so it is actually 19 6/10. And now when we add that to our first term, we get what? 23.8, 23 8/10. The 15th term is 23 8/10. Seem reasonable?
Yes.
Is that another check it out problem?
Yes.
Did you do it right?
Yes.
Because if you didn't, you might want to have it right, okay? Questions on finding a later term of an arithmetic sequence? Yes, Andrew?
The back of the book, it says it's 19.6.
In the back of the book is wrong. You got it? Okay, so what do we do wrong then?
So,
So that's what I got my second term. Yeah, but 2B says it's the 12th term, not the 12th.
Oh, well then I changed it up for the notes. Okay, we found a 15th term then. So this isn't exactly the one in your check it out, is it? Thanks for catching that, Morgan. We don't want to think that the back of the book was wrong. The back of the book is right for the 12th term, and ours is larger. Should ours be larger? Yes, because we found 3 terms later. Okay, let's go to the check it out problem that you did this also in your SQ3R. Let's see how that went. What's going on in this problem? Talk to me about it. Tell me one thing, Caden.
It's, the cargo's decreasing after each stop. So
Okay, so there's cargo in some sort of a transport vehicle apparently, and it's decreasing, you're saying, so after each stop, so apparently they're unloading? Okay. What else? What do they want?
6 stops.
They want to know what after 6 stops. How much cargo is still on the transport vehicle? Okay. So do we have enough information? Were we given what they started with?
2000.
No, they don't start with it, that's what it was after stop. After stop 1, it was 2,000 pounds.
Okay, that actually is stop. The term numbers are the stops in this one. So stop 1 is the 2,000, stop 2, stop 3, stop 4, stop 5, and stop 6. So when they say stop 1, those term numbers are, so in reality, they actually, when they started on this truck, how many pounds did it actually have on it to start with? 2,250. But in an arithmetic sequence, the first term will be whatever's going on, like these are stops or whatever, the case is. So our A sub 1 is the 2,000, the first term of our sequence. We are looking for the amount on the truck after 6 stops, and what's our D value?
-50.
Okay, is that negative a big deal?
Yes.
Absolutely. What's going to happen if you don't have a negative there?
You're gonna get it, it's gonna gain.
It's gaining. You're going to end up with more pounds than it started with at stop 1. So we have to make sure that we make it negative when it should be. It's dropping off 250 pounds. So A sub 6 equals, what do we put in next?
2,000.
2,000 plus
6 minus 1.
6 minus 1 in parentheses times
Negative 250.
negative 250. Okay. Okay. 6 minus 1 is
5.
5. So how many pounds is coming off that truck in those other 5 stops?
Negative, or 1,200.
Yeah, so it's going down another 1,250 pounds. That's how much more is coming off. And we should be left with 750, and these are what? Pounds. Okay, pounds. After stop 6, there should be 750 pounds left on that truck or transport vehicle, whatever it was. Okay? So, hopefully this just confirms you did your SQ3Rs right, or if you still had questions, hopefully they've now been answered. Does anybody have anything you still need to ask about? You take a quiz on this tomorrow. Okay, then we're going to get you to work.